Rational equations are equations that involve fractions. There are several ways of solving them, but I'll show you the way that I like the best. I like to eliminate fractions early in the problem and work with the resulting equation. We do this by finding the least common denominator of all the denominators and multiplying both sides of the equation by that least common denominator. In this example, the denominators are 5 and 3, so the least common denominator is 15. So if I multiply both sides of the equation by 15, I can cancel on the left-hand side, leaving me with 3 and 1. So the left side of the equation is 3 times 4x plus 2. On the right side of the equation, if I cancel down the 3 and the 15 down to 1 and 5, I have 5 times x minus 3. And in one step, I've eliminated the fractions in the problem. Now I have a simple algebraic equation to solve. Let me distribute on the left-hand side and the right-hand side. Let me subtract 5x from both sides. Let me subtract 6 from both sides. And let me divide both sides by 7. I have an answer of x equals negative 3. I can check my answer by plugging negative 3 back in the original problem and seeing if it makes the original equation true. So here, let me make the substitution of negative 3 for each of the x's. If I simplify, on the left-hand side, I have negative 2. On the right-hand side, I also have negative 2, so my answer checks. In this particular problem, we had one fraction equal to another fraction, so I could have used the method of cross multiplication. Let me work the problem using that method. Cross multiplication can only be used when we have one fraction equal to another. I'm multiplying across the equal sign 3 times 4x plus 2 and 5 times x minus 3. If I continue the solution, subtracting the 5x from both sides, subtracting 6 from both sides, dividing by 7, I also get negative 3. So both solutions are fine. They're both equivalent in what's actually happening in the problem. Let's look at another example. I cannot use the cross multiplication procedure in this case because I don't just have one fraction equal to another, unless I would combine this entire left side into one fraction, but I'm not going to do that. But I can use the first method that I showed, where I can multiply each side by the least common denominator. In this case, when you see the denominators of 4, 3, and 6, the least common denominator would be 12. They all divide into 12. So let's multiply each side by 12, and I'll show that by distributing 12 throughout the left-hand side and multiplied by the right-hand side. So in effect, I've multiplied both sides by 12. I just distributed on the left-hand side. Or notice that I've multiplied each fraction by the same number. If I reduce each fraction, 12 and 4 cancel down to 3 and 1, so I have 3 times x plus 2. 12 and 3 cancel down to 1 and 4, give me 4 times 2. And 12 and 6 cancel down to 2 and 1, leave me with 2 times x plus 3. Again, in one step, I don't have any more fractions. I have a simple equation, simple linear equation that I can solve. Distribute the 3. distribute the two. I can combine like terms on the left-hand side. I can subtract 2x from both sides. X plus 14 equals 6. I can subtract 14 from both sides. X equals negative 8. If I check my answer, plugging negative 8 in for all of the x's, negative 8 plus 2 over 4 plus 2/3, and I want to see if that equals negative 8 plus 3 all over 6. If I simplify this left-hand side that's at the top, I have negative 6 over 4 plus 2/3. This is negative 3/2 plus 2/3. I need the same denominator, so let's multiply this first fraction top and bottom by 3. Multiply top and bottom of this other fraction by 2. And I get negative 5/6. On the right-hand side, if I simplify that, I also get negative 5/6, so this answer checks out. Another example. In this example, I have denominators of x minus 2, x plus 3, and then x squared plus x minus 6. I want to factor this down, the x squared plus x minus 6, to see if that is my least common denominator of all the denominators. So let me bring everything else down that I haven't used yet and factor down that last denominator. It factors into x plus 3, x minus 2, which is my least common denominator. So I can multiply each fraction by x minus 2, x plus 3. In the first fraction, the x minus 2's cancel. I'm left with 6 times x plus 3. I'll distribute that right away. 6x plus 18. In the second fraction, x plus 3's cancel. I have a positive 5 to distribute. And on the other side, the x minus 2's cancel. The x plus 3's cancel. I'm left with 6x plus 3. If I simplify the left-hand side, I have 11x plus 8 equals 6x plus 3. I can subtract 6x from both sides. I can subtract 8 from both sides. And I can divide both sides by negative 1. Or, I'm sorry, divide both sides by 5. And I get a solution, x equals negative 1. Checking that answer, I have 6 over negative 1 minus 2, plus 5 over negative 1 plus 3. I want to see if that's equivalent to 6 times negative 1 plus 3 over negative 1 squared plus negative 1 minus 6. On the left-hand side, I have 6 over negative 3 plus 5 over 2. If I change both of these to sixths, I have negative 12 sixths plus 15 sixths, which is 3/6 or 1/2. On the other side, if I simplify this fraction, I have -3 or -3 over 1 minus 1 is 0 minus 6. I also have 1/2, so it checks out. Let me give you a practice problem. Solve this equation, stop the video, solve the equation, and then come back to the video to check your answer. In this equation, my denominator in the middle fraction can be factored down, so let me factor it down. X plus 4, x minus 4. My least common denominator is x plus 4, x minus 4, so let's multiply each fraction by x plus 4, x minus 4. On the left, in the first fraction, the x minus 4's cancel. If I distribute the 8, I have 8x plus 32. In the second fraction, the x plus 4's cancel, the x minus 4's cancel. I have a negative to distribute throughout the 9x minus 2. And on the right-hand side, the x plus 4's cancel. I distribute the 4 throughout the x minus 4. If I simplify the left-hand side, negative x plus 34 equals 4x minus 16. I will add x to both sides. I will add 16 to both sides. And I will divide both sides by 5. I have an answer of x equals 10. Let me check that answer. On the left-hand side, I would have 8 over 10 minus 4, minus 9 times 10 minus 2, over 10 squared minus 16. On the right-hand side, I would have 4 over 10 plus 4. That's 4 over 14, or 2/7. If I simplify this left-hand side, I have 8 over 6 minus 90 minus 2 is 88 over 100 minus 16 is 84. If I multiply top and bottom of the first fraction by 14, I'll have 112 over 84 minus 88 over 84. If I subtract, I'll have 24 over 84, which if I divide top and bottom by 12, I have 2/7, so it checks out. The answer is 10. Again, the method I like to use for solving the rational equations is to eliminate the fractions right away by multiplying every fraction in the equation by the least common denominator. That gets rid of the fractions, and we can solve the equation that results from that.